Searching for traces of intelligent extraterrestrial life is as difficult as finding a needle in the ocean. Even the SETI project, in which leading scientists have used large and modern radio telescopes to search for signals from aliens for decades, has yet to succeed to this day. However, a recent report on an astronomical research project conducted by a team of students from the University of Toronto in Canada and published in the journal Nature Astronomy on January 30th, has brought new hope. This study suggests that artificial intelligence, AI, could significantly enhance the efficiency of searching for signals from intelligent extraterrestrial life. A newly developed algorithm by the research team detected up to 8 suspicious signals after analyzing a massive dataset of 150 terabytes. This data came from a skyscan using the Green Bank telescope in West Virginia, USA, covering 820 stars. The detected signals originated from 5 stars located about 30 to 90 light-years from Earth. These signals are considered potential alien transmissions because they appeared clearly when the radio telescope was directed at their source, but disappeared when the telescope was pointed elsewhere. Dr. Steve Croft, a scientist at SETI working at the Green Bank telescope, stated, "This is proof that the signals are not terrestrial interference, which typically appears constantly. The signals detected by AI also change frequency over time, making them appear to come from a moving source." However, it has not been confirmed whether these signals truly come from aliens. When the research team continued monitoring them for a while, no repeated occurrences of the same signals were observed. Previously, the research team trained a self-learning algorithm to analyze extraterrestrial radio signals, focusing on enabling AI to distinguish between human-made interference and signals that could be from advanced alien technology. Peter Ma, an undergraduate student leading the research project, stated that while the 8 signals discovered may be coincidental and require long-term observation to confirm their extraterrestrial origin, their study at least demonstrates AI's immense potential in the field of astrobiology. Our new technique, which combines AI with powerful next-generation radio telescopes like MeerKAT or NGVLA, will elevate alien searches from scanning hundreds of stars at a time to scanning millions of stars simultaneously, Peter Ma said. Recently, astronomers detected the most distant light signal ever found from another galaxy. On January 20th, 2023, India's GMRT radio telescope detected light signals from hydrogen atoms, which traveled as radio waves through deep space for 8.8 billion years before reaching Earth. These signals provide insight into the universe's past when it was about 5 billion years old. This is the farthest traveling astronomical evidence ever discovered for neutral hydrogen atoms, making it one of the oldest signals close to the Big Bang. The signals originated from the galaxy SDS-SJ 0826 plus 5630, known for its high star formation rate. This galaxy emits various types of radio signals, including those from neutral hydrogen atoms, which appear as light waves. These light waves initially had a wavelength of 21 centimeters, but stretched to 48 centimeters by the time they reached Earth due to redshift, the phenomenon where light waves elongate and lose energy as they move away from their source. To enhance the detection of weak low-energy signals, researchers used gravitational lensing. The gravitational pull of a massive galaxy between Earth and the signal source bent and magnified the light, much like a magnifying glass. GMRT is among the world's most sensitive radio telescopes for detecting deep space radio waves in the 30 to 1500 MHz frequency range. This detection of the farthest hydrogen light signal broke the previous record of 4.4 billion years set by the Chile's Space Survey project. The research team published their findings in the journal MNRAS of the Royal Astronomical Society in London, noting that this discovery provides new hope for studying the universe's history through methods such as investigating the evolution of interstellar gas. Future low-frequency radio telescopes could further enhance such studies. What exactly are the mysterious radio signals bursting from deep space? One example of these mysterious signals was discovered by a team of Canadian astronomers who detected fast radio bursts, FRBs, from deep space, 1.5 billion light-years away. This marked only the second time that such mysterious signals were observed to repeat from the same source. The findings, published in Nature, reported that the KIME radio telescope in British Columbia, Canada, detected 13 bursts of FRBs during the summer of the previous year. Previously, FRBs were an astronomical enigma. These high-energy radio bursts last only a few milliseconds, and their origins in the universe remain unknown. Since their first discovery in 2007, dozens have been recorded, totaling 60 detections to date. However, only 2 cases involved repeated signals from the same source. Several theories have been proposed regarding the origin of FRBs, ranging from neutron stars and black holes to intelligent extraterrestrial life. Rapidly spinning neutron stars in a magnetic field. When a massive star reaches the end of its life and undergoes a violent explosion, it may collapse into an extremely dense, rapidly spinning neutron star. If such a star exists in a highly magnetized space, it could generate mysterious signals that travel across the universe. Dr. Ingrid Stairs, an astrophysicist at the University of British Columbia, suggested that this hypothesis is highly plausible. However, scientists have yet to definitively confirm the exact cause of FRBs. Merging neutron star pairs. When 2 neutron stars collide and merge, the event releases gravitational waves and powerful energy bursts. However, this explanation applies only to single-occurrence FRBs. A neutron star collision produces only a one-time burst as the 2 stars merge and are destroyed. Thus, this theory cannot explain repeated FRBs from the same source, said Dr. Sriharsh Tendulkar, an astronomer at McGill University. Blitzars. A blitzar occurs when a rapidly spinning neutron star collapses under its own immense mass, forming a black hole. This could generate an FRB, but like merging neutron stars, it would produce only a one-time burst. Black holes. Several hypotheses suggest that black holes could emit FRBs, such as when a neutron star falls into a black hole, the black hole collapses, or dark matter interacts with it. Intelligent extraterrestrial life. Although most astronomers believe that FRBs occur naturally, some suggest they might be signals from intelligent extraterrestrial civilizations, either deliberate transmissions or unintended byproducts of advanced technology. In 2017, a group of scientists from Harvard University proposed that FRBs could be energy leaks from an alien communication device, possibly the size of a planet. They speculated that such a device might not be used for communication, but as a propulsion system, similar to a solar sail, using beams of radio waves to push spacecraft through space. However, Dr. Stairs argued, FRBs come from diverse and scattered sources across the universe. It is unlikely that multiple extraterrestrial civilizations are using identical methods to produce the same kind of signal. If you like space stories, you are our friend. Click follow and press the bell so you don't miss any action.